This video covers how to write a function of x from an integral. So let's start with this example. Let f of x be the integral from 1 to 2x of the sine of t squared dt. We're going to use our calculator to find the second derivative of x when x equals 1. So this takes us back to module 5 where you learned the fundamental theorem, and one of the parts talks about taking the derivative of an integral, and it should be a red flag when you see an integral with a function of x as one of the limits of integration. You should think derivative and this formula. So it's usually red flag. You don't see that very often. So most likely you're going to end up taking the derivative of this thing. And the derivative is where you take this and you plug it into the function and then you multiply by the derivative of this. So in this case, we're going to take 2x and we're going to plug it in to t and we're going to square it, and then we're going to multiply by the derivative of 2x. So our first derivative of x is the sine of 2x squared times 2. Plug this in and then multiply by this derivative. So let's simplify that a bit. 2 goes out front, and this is now 2x times 2x. Okay, so we need the second derivative though, so let's take the derivative again. We're going to need to use the chain rule because this is a composite function. There's 2 layers here. The 2 is a constant, so we can multiply that out at the end. And we end up with the derivative of sine first. This stays the same, and then derivative of 4x squared. So this derivative of sine is cosine, leave the inside alone, and then take the derivative of the inside. Okay, so everything's being multiplied here. We have a 2, we have times that cosine times 8x, so let me make that a 16x in the front times that cosine piece. And that's really it. You just need to plug in 1 right now. So 16 times 1, and then the cosine of 4 times 1 squared. So we end up with 16 times the cosine of 4. We need a calculator for this. And that's it. Okay, I can't say the next one is as simple. So let's move on and use the graph of f of t equals negative 2t plus 3 on the interval negative 4 to 6 to write the function f of x, where f of x equals that integral defined by 1 to x of f of t. Okay, so where do we start? Well, f of x equals this integral. I just replace f of t with the actual equation for f of t. And now, just like we did the last one, we're going to take the derivative. The derivative of f of x, plug this in to the t, and multiply by the derivative of this, which is just 1. So the derivative of f is negative 2x plus 3. So if we want an equation for f of x, let's go backwards now. So we just took derivative. Now let's go backwards from derivative to function. If you want a function, you integrate its derivative. So we're going to integrate this. Let's integrate it like normal. Power rule here, we're going to end up with x squared over 2, and those 2's are going to cancel. And then this will be 3x plus c. So we don't know anything about anything in terms of limits of integration, so we have this plus c here. So this is not the final answer. It needs to be particular. So this is usually where we get stuck. So let me take you back again. We need a condition to find c. You've done this. You did this in module 7. I think that's where it was introduced. So for example, this is a sidebar. Pretend that we're not doing this problem for a minute. Let's just pretend that we have our velocity function is equal to 3t squared. And the directions are asking you to find the particular s of t equation given this initial condition. That's an initial condition because they gave us the starting point when time is 0. It's considered a condition, but in this case, it's initial. I'm quoting my fingers right now. Initial because it's t equals 0. But we don't necessarily have to have the initial condition. We just need a point to plug in. We need something to plug in so we can figure out what that what that unknown is. Okay, so we know that the position function would be the integral of the velocity or the derivative. So integrate 3t squared. Use the power rule again. This will be t cubed over 3. Those 3's cancel, plus c. So this is where you would go. It's the same thing. We're like at the same step right now. So you would take your t equals 0 and your function value equals 1 and plug it right in. And in this case, c equals 1. Now you go back and you go to s of t is t cubed plus 1. This is something you've been doing. You learned this in the last chapter. So we're doing the exact same thing here, except we weren't given any conditions straightforward, like directly. It didn't spell it out for us. So here's the thing. We know that just from the given, we do know that they gave us this, which is negative 2t plus 3. And we can use that to find a condition. You can choose any value for x. It just has to be greater than 1 because like the domain stuff, it can't be less than 1. So greater than 1. And we can integrate to figure out what the value of f of x is. You can literally pick any value of x and stick it in here and integrate a definite integral like you've been doing since chapter 5, as long as it's bigger than 1. So you can do that and that'll give you a point. However, let's make it easy. Since we can pick anything we want, let's pick 1. So it will give us a 0 when we integrate. If we integrate anything from like a to itself, just like that domain video, if you watched it, it talked about like we're not going anywhere. We're not finding any area. There's no area if you don't go from 1 to some other number greater than 1. So you could pick any number you want and integrate and use the fundamental theorem in the subtraction and find a value, but I'm going to pick 1 because the integral from 1 to 1 equals 0. So now I just plugged in a 1 for x. Remember, this is my function right now. I plugged a 1 in for x, and my result was 0. So f of 1 equals 0. Let's go back here now because we have a condition. This is a condition. We just made it. It doesn't have to be this condition. You could make your own. If you don't trust me, do something else. Pick a different value for x. Okay, so now we know that f of 1 equals 0, so that means all the x's are 1. The f of x value is 0. Plug it in. Be careful with this negative sign right here because it's really 1 squared. It's a negative 1 times x squared. So that ends up being a negative 1 plus a 3. We get 2. C equals negative 2. Therefore, our function, particular, negative x squared plus 3x minus 2. Not so bad when the calculus teacher shows you how, huh? All right, good luck.